Hello friends, welcome to lecture series on matrix analysis with applications. So, in the last lecture we have seen that how can we solve homogeneous system of linear equations. We have seen that if we have a system of equation like this Ax equal to 0, where A is a matrix of order m cross n, you see A11, A12 up to A1n and AM1, AM2 up to Amn, which is a matrix of order m cross n, and x is a vector, it is x1, x2 up to xn, okay, n cross 1. So, this A is called coefficient matrix and this x is called a known vector, which is to find out. So, we have seen that while solving a homogeneous system of equation when right hand side is 0, so this system is always consistent, because at least x equal to 0 is a solution which satisfy this system of equations, linear system of equations. So, this is always consistent, and if it is consistent, so there is only two possibilities, either it has a unique solution or it has infinitely many solution. So, when it will be having unique solution means 0 solution or the trivial solution, when rank of A is equal to number of unknowns, then it will be having unique solution, okay, or trivial solution. We also call it trivial solution, which is a 0 solution. And if rank of A is less than n, that means number of linearly independent equations are less than number of unknowns, then the system will be having infinitely many solutions, okay. So, this we have seen the last lecture, that how can we solve system of homogeneous linear system of equations. Now, if we are having system of non-homogeneous equation, that is Ax equals to b, which is a linear system of equation, but non-homogeneous. Non-homogeneous means b vector is not equal to 0, okay. A is the coefficient matrix which is of order m cross n, okay. X is a vector which is to find out x1, x2 up to xn, and this b is a vector which is b1, b2 up to bm, and this is not equal to 0, because if it is 0, then this will be the homogeneous system of equations. And now we are interested to find out the solution of non-homogeneous system of equations. Now, to find out the solution of this system, so there are three possibilities. Either system will be having no solution or inconsistent, or unique solution, that is only one solution, or infinitely many solutions. Now, how can we see, how can we find out where this system has unique solution, many solution or no solution? So, we first construct a new matrix which we call as augmented matrix. So, what is augmented matrix? You see, augmented matrix is given by, we denote it by A slash B. This matrix is augmented matrix, and the augmented matrix means you first write A. A is A11, A12 up to AM1m, 1n, this A21, A22 up to A2n, and then AM1, AM2 and Amn, which is a m cross n matrix. This is a A matrix, this A matrix, okay. And then your right hand side is B1, B2 up to Bm. So, this matrix is called augmented matrix. Now, what is the order of this matrix? Now, you see there are m rows in this matrix and number of columns are n plus 1. So, the order of this matrix is m cross n plus 1. Now, of course, if you find the rank of this matrix, rank of augmented matrix, it will be always greater or equal to rank of A, rank of A, okay. Why it is always greater than equal to? Because because augmented matrix is basically having a higher order than the order of A. A is simply of order m cross n, and you add one more column in the A matrix to get augmented matrix. So, it has a order m cross n plus 1 which is of higher order than the order m cross n. So, the rank of A will always, rank of augmented matrix will always be greater than or equal to rank of A. Okay. Now, so we have seen that rank of augmented matrix will always be greater than or equal to rank of A. Okay. So, augmented matrix has order m cross n plus 1, while A matrix has a order m cross n. Okay. Now, there are two possibilities. Number 1, either rank of A augmented matrix is equal to rank of A, or rank of augmented matrix is greater than rank of A. Greater than means not equal to. Okay. Now, if rank of augmented matrix is equal to rank of A, what does it mean? You see, what is the augmented matrix we are having? Augmented matrix is given by, it is A11, A12, A1n, A21, A22, A2n and so on, AM1, AM2, AMN, and this is B vector B1, B2 up to Bn, Bm. Now, we have seen that the first case we are discussing, that what happens if the rank of A augmented matrix is equal to rank of A. What does it imply? Whether it implies that the system is consistent or whether it implies the system is inconsistent. How can we say? So, let us discuss this thing. We first find augmented matrix here. Now, this is matrix A, okay, and the rank of A is same as rank of augmented matrix, that is number of linearly independent rows or columns it is having, this matrix A is having the same number of rows and columns, the same maximum number of rows and columns the entire matrix which is augmented matrix have. That means what? Or we can say that linearly independent columns of matrix A will be same as linearly independent, maximum linearly independent columns of augmented matrix, the full matrix, and that is possible only when this column, the extra column, can be written as linear combination of these columns. If you are taking this as column 1, this as column 2 and this as column n, and this vector we are taking as B, suppose, okay, and we know that rank of this A matrix is the same as rank of the entire matrix. This means maximum linearly independent columns of matrix A will be same as the maximum linearly independent columns of augmented matrix, and this means that this vector B can be expressed as linear combination of C1 vector, C2 vector up to Cn vector, then only it will be possible that rank of augmented matrix will be same as rank of A. So, what does it mean basically? This means this vector B can be represented by some linear combinations of these column vectors. Okay. Okay. Now, what is B? B is simply B1, B2 up to Bm. Alpha 1 times, what is C1? C1 is A11, A21 and so on up to AM1. What is C2? C2 is A12, A22 and so on up to AM2. And what is Cn? Cn is A1n, A2n and so on up to Amn. So, this means B1 will be equal to, this means there exists some alpha 1, alpha 2 up to alpha n such that B can be expressed as linear combination of these column vectors. So, now this implies that B1 will be equal to alpha 1 times A11 plus alpha 2 times A12 plus alpha n times A1n. Similarly, B2 can be written as alpha 1 times A21 plus alpha 2 times A22 and so on plus alpha n times A2n, and similarly the mth equation. So, what it is basically? It is simply A into alpha 1 up to alpha m is alpha n and it is equal to vector B. That means, in place of x1 we are having alpha 1, in place of x2 we are having alpha 2, in place of xn we are having alpha n. That means, we have shown the existence of the solution of this linear system of equations. Hence, we can say that solution exists if rank of augmented matrix is same as rank of A. Okay. So, we can say that if rank of augmented matrix is equal to rank of A, this implies solution exists or system is consistent, we can say. Now, if system is consistent, there are two possibilities: either it has having unique solution or it has having infinitely many solutions. Now, if it is having unique solution, so when it will be having unique solution, you see, it will be having unique solution only when number of linearly independent equations, linear equations will be same as number of unknowns, and that will be possible only when rank of augmented matrix, which is same as rank of A, should be equal to number of unknowns. Then only this means that number of linearly independent equations are same as number of unknowns, because rank of A means linearly maximum number of linear independent rows or columns. Okay. And if it is equal to number of unknowns, this means number of linearly independent equations are same as number of unknowns, this means unique solution. Now, when it will be having infinitely many solution, if rank of augmented matrix will be equal to rank of A and will be less than number of unknowns. Okay. Then it will be having infinitely many solution. Okay. The reason is very simple. You see, if rank of A or rank of augmented matrix are same and it represent number of linearly independent equations, and if they are less than number of unknowns, this means equation are less and number of unknowns are more. Number of linearly independent equations are less and number of unknowns are more, this means infinitely many solutions. Okay. Now, the second case is, if the second case is, you see, the second case is if rank of augmented matrix is more than rank of A. The second possibility, if rank of augmented matrix is more than rank of A, so what does it mean? You see, augmented matrix is what? We have discussed augmented matrix is A11, A12 and so on up to A1n, A21, A22 and so on up to A2n. Here it is mth row is AM1, AM2 and so on AMN, and here it is B1, B2 up to Bm. Now, if rank of augmented matrix is not equal to rank of A or rank of augmented matrix is more than rank of A, this means in the echelon form of this matrix, you see, if rank of this matrix A is less than rank of the entire matrix, okay, this means this will be possible only when in the echelon form of this matrix A there is a row which contains all 0 and corresponding Bi is not equal to 0. Okay. You can simply see that if it is 0, the entire row, the last row is 0 and this is not equal to 0, then what is the rank of this matrix? Rank will be m, for example. okay, and rank will be m minus 1 and here it is m. So, what I want to say that rank of augmented matrix will be more than the rank of A only when in the echelon form of the augmented matrix you will be having one row, entire row having 0 in A and the corresponding BI is not equal to 0, and this means what? This means that that 0 is equal to some non-zero quantity, which is not possible. So, system is inconsistent, in this case system is inconsistent or no solution. Okay. So, let us discuss based on this, let us discuss few things, few properties. This we have already discussed that system of non-homogeneous equation is given by Ax equal to B, where B is not equal to 0. Okay. These are coefficient matrix, this is unknown and this vector is right hand side. Augmented matrix is defined like this, you see that we first write the matrix A and then the right hand side. This entire matrix is called augmented matrix. Its order is m cross n plus 1 and clearly rank of A plus rank of augmented matrix is greater than or equal to rank of A. Now, if you talk about consistency or inconsistency in the system of linear equations, then we have already discussed that if rank of augmented matrix is not equal to rank of A, not equal to means greater than, this means system is inconsistent, and if rank of augmented matrix is equal to rank of A is equal to R, which is R here, then this means consistent, and if this R equal to number of unknowns means unique solution, if this R is less than n, this means infinitely many solutions, as we have already discussed. Now, let us discuss a few examples based on this. Okay. The first example is, you can see here we are having 3 equations, and how many unknowns we are having? We are having 4 unknowns. Okay. So, x1, x2, x3, x4, these are the unknowns and these are 3 equations. So, you first write augmented matrix of this equation. Okay. So, how can we write? Let us see. Okay. So, what is the augmented matrix we are having here? You can see the augmented matrix is basically, here the augmented matrix is given by 1, 1, minus 2, 4, the right hand side is first 5, then 2, 2, minus 3, 1, then 3, then 3, 3, minus 4, minus 2, 1. These are augmented matrix. Okay. Now, if you see here, the first equation is x1 plus x2 minus 2x3 plus 4x4 equal to 5. The second equation is 2x1 plus 2x2 minus 3x3 plus x4 equal to 3. Third equation is 3x1 plus 3x2 plus minus 4x3 minus 2x4 equal to 1. Now, the first important property is when you apply elementary row operations on the system of linear equations, it will not change the solution. It may change the equations, but the solution set remain unchanged. Okay. So, you first find the echelon form of this matrix. You see, you leave first row as it is, you make 0 in the second row of the first element with the help of the first element, first leading non-zero element. So, what operation you will apply? R2 minus twice of R1. So, this is 0, this is 0, this minus 2 times this will be 1, this minus 2 times this will be minus 7, this minus 2 times this will be again minus 7. Now, in the third row you will apply the operation third row minus 3 times first row to make 0 here. So, this minus 3 times this will be 0, this minus 3 times this again will be 0, this minus 3 times this, that is minus 4 plus 6 is 2, okay, and this minus 3 times this. So, it is minus 2 minus 12, that is minus 14, and this minus 3 times this is again minus 14. Okay. So, now you will make the first leading non-zero element in the second row is 1, you will make 0 below this element. So, how to make 0 here? You will make this minus 2 times this. So, in the next step the first row remain unchanged, the second row remain unchanged again, and the third row you will take third row minus twice of second row. So, this is 0, 0, 0, 0 and 0. Now, what is the rank of A? Rank of this matrix A? There is simply 2, number of non-zero rows is 2. And what is the rank of augmented matrix or the entire matrix? The rank of entire matrix is also 2. So, rank of A, this implies rank of A is equal to rank of augmented matrix, which is equal to 2. So, rank is equal, this means system is consistent. How many unknowns it is having? It is having 4 unknowns. So, it is less than 4. This means it is having infinitely many solutions. Now, how you will find the solution? You will arbitrarily, because now we are having 2 independent equations. The first equation is, you can simply see, the first equation from here is what? From here the first independent equation is x1 plus x2 minus 2x3 plus 4x4 equal to 5. The second equation is x3 minus 7x4 equal to minus 7. So, these are 2 linearly independent equations and we are having 4 unknowns. So, you can take 2 variables as arbitrary values and find out the remaining 2 in terms of that. Okay. So, that is what we have discussed in the solution. You can take x4 as a k1, x1 as k2, then you can find x2 as this and x3 as this, where k1 and k2 are any real numbers. Okay. Now, let us discuss the second problem. The second problem is again having 4 unknowns and 3 equations. So, how can we solve this problem? Again we will find the augmented matrix, convert the augmented matrix into the echelon form, find the rank of A, rank of augmented matrix, and then we can see whether system is consistent or inconsistent. Okay. So, let us discuss this example also. You see, augmented matrix here is what? Augmented matrix here is 1, 1, minus 2, 3 and 4. It is 2, 3, 3, minus 1 and 3. It is 5, 7, 4, 1, 5. This is the augmented matrix of this problem. Now, you will try to find its echelon form. You leave the first row as it is. Now, make 0 here with the help of this. So, this minus 2 times this is 0, this minus 2 times this is 1, this minus 2 times this is 7, this minus 2 times this is minus 1 minus 6 is minus 7, this minus 2 times this is 3 minus 12, 3 minus 12 is minus 9. Okay. This minus 5 times this, so 0, this minus 5 times this is 2, this minus 5 times this is 14, this minus 5 times this, that is 1 minus 15, that is minus 14, and this minus 5 times this is 5 minus 20 is minus 15. Okay. So, what we have obtained here, what we have observed. Now, it is not a echelon form, you have to make 0 here with the help of this. So, how you will make this? Again take this row as it is, 0, 1, 7, minus 7, minus 9, this minus 2 times this will make 0, 0, 0, 0. However, this is not equal to 0. When you take this minus 2 times this is minus 15 plus 18. So, this is 3. So, here rank of A is 2, okay. This rank is A is 2. However, rank of the entire matrix is 3. So, rank of A is not equal to rank of augmented matrix, this means no solution. Okay. So, system is having no solution. Now, we come to third problem. Here we are having 3 equations with 3 unknowns. Okay. Now, so to find out whether the system is consistent or inconsistent, or it is having many solution or no solution or unique solution, we first find its augmented matrix. Okay. This is 1, 2, 1, 3, 1, 2, 1, 3, 2, 5, minus 1, minus 4, 2, 5, minus 1, minus 4, the second row. The third row is 3, minus 2, minus 1, 5, 3, minus 2, minus 1, 5. Now, you find out the echelon form of this matrix, which is this. You can easily find out the echelon form of this matrix by making 0 here and 0 here and then 0 here. Okay. So, clearly the rank of this matrix A, which is this matrix, the rank of this matrix is 3, because number of linearly independent rows it is having are 3, and the rank of the entire matrix is also 3. So, rank of A is equal to rank of augmented matrix is equal to 3, which is equal to number of unknowns. Unknowns are also 3. So, that means system is having unique solution. Now, how to find that solution? Now, to find out that solution is simple. You can simply see, what is the first equation? The first equation is x1 plus 2x2 plus x3 equal to 3. You can see the first equation from here, x1 plus 2x2 plus x3 equal to 3. What is second equation? x2 minus 3x3 equal to minus 10. x2 minus 3x3 equal to minus 10. And what is your third equation? Third equation is minus 2x3 minus 28x3 equal to minus 84. So, minus 28x3 equal to minus 84. So, that means instead of solving from here, we solve it from the echelon form of this matrix, because we know that when we apply elementary row operation or system of linear equations, it will not change the solution will remain unchanged. So, what are the equations we are having here? The first equation is x1 plus 2x2 plus x3 equal to 3. The second equation is x2 minus 3x3 equal to minus 10. The third equation is minus 28x3 equal to minus 84. Now, we will apply back substitution. So, how we will apply back substitution? From here we got x3 as, you can simply see x3 is 3. Okay. Now, you substitute x3 over here. If you put x3 equal to 3 here, so x2 will be minus 10 plus 3 x3, and x3 is 3, so it is minus 1. And from here x1 will be, when you substitute x2 as minus 1, so it is minus 2, minus 2 plus 3, minus 2 plus 3 is 1, 3 minus 1 is 2. So, this is a solution of this equation. So, we go by back substitution. Okay. So, this is a solution of this system. Now, let us find out, let us solve this problem, where we have to find out the conditions on lambda and mu such that this system is having no solution, unique solution or infinitely many solutions. That means, what should be the values of this lambda and mu, so that this system is having no solution, unique or infinitely many solutions. So, how can we see this? How can we find out? So, we again find out the echelon form of this matrix. Okay. So, let us try to find it. So, what is the augmented matrix of this problem? This will be, this is 1 1 1 6, the first equation. The second equation is 1 2 3 10. The third equation is 1 2 lambda and mu. Okay. Now, we have to first find out the echelon form of this matrix. So, how to find the echelon form? You can see it is 1 1 1. First row remain as it is, because this is 1, no change, I mean this is non-zero. Okay. Now, you will make 0 here with the help of this. So, R2, in R2 you will make R2 minus R1. So, this is 0, this is 1, this is 2, this is 4. Now, you will make 0 here with the help of this. So, in R3 you will apply an operation, that is R3 minus R2, R1. So, this is 0, this is 1, this is lambda minus 1, this is mu minus 6. Okay. Still it is not an echelon form of this matrix, because it is 1. So, you will make 0 here with the help of this. So, it is 1 1 1 6, it is 0 1 2 4. So, in R3 you will apply an operation R3 minus R2. So, it is 0 0 lambda minus 3 and mu minus 10. So, this is the echelon form of this matrix. Now, first is no solution. Okay. For no solution, rank of A should not equal to rank of augmented matrix, or we can say that rank of augmented matrix will always be more than rank of A if it is having no solution. Now, the rank of A cannot be less than 2 because we have seen that this is A. Okay. Now, we have seen that there are 2 non-zero rows it is having. So, rank of A is at least 2. Okay. It will be 3 if lambda is not equal to 3, and it will be 2 if lambda equal to 3. Okay. Now, we want rank of augmented matrix more than rank of A. Okay. So, if lambda is equal to 3, then rank of this matrix is 2, and we want rank of this matrix as 3. So, this entire matrix rank will be 3 if mu minus 10 is not equal to 0, that is mu should not equal to 10. Then only if lambda is equal to 3, this means rank of this matrix is 2. Okay. And if mu is not equal to 10, that means rank of the entire matrix is 3. So, that means ranks are not same, that means no solution. This is the only possibility. Okay. So, if this happen, then no solution. Now, second case is many solutions or infinitely many solutions. For many solution, rank of A should be equal to rank of augmented matrix and should be less than number of unknowns. Now, here unknowns are 3. So, rank must be less than 3, and less than 3 means either 1 or 2, and we have seen that rank of A is at least 2. So, that means 2, because we want it less than 3, less than 3 means either 1 or 2, and rank of 2 is at least 2. So, that means equal to 2. Okay. That means equal to 2 or less than 3. This is the only possibility. Okay. Now, this implies, now rank of this is 2 when lambda equal to 3, and rank of this entire matrix is also 2 if mu equal to 10, if mu equal to 10. Yeah. Okay. So, if this happens, then it is having many solutions, infinitely many solutions. Now, the third case is unique solution. For unique solution, rank of this should be equal to rank of augmented matrix and should be equal to 3. Now, rank of A is 3 if lambda minus if lambda minus 3 is not equal to 0 or lambda is not equal to 3. Okay. So, if lambda is not equal to 3. Now, if lambda is not equal to 3, the rank of this matrix A is 3, and whatever the value of mu may be, the rank of the entire matrix is also 3. So, mu may belongs to R. So, this is the condition on lambda and mu, so that it is having unique solution. For this values it is having many solution, and for these values it is having no solution. So, this is how we can find out whether the linear system of equations has unique solution, no solution or many solutions. Okay. So, in the next class we will see about vector spaces, that what vector spaces are and how they are important for solving some problems. Okay. So, thank you very much.